So in the test review, the first part starts with the first 20 perfect squares. So this is just literally asking you to square numbers 1 through 20. So 1 squared is 1, 2 squared is 4, which is 2 times 2, 3 squared is 9, which is 3 times 3, 4 squared is 16. So you would go all the way, if you look down the side over here, all the way down to 20 working those. Alright, so that helps you then start solving some of these. So we're supposed to simplify the radicals. So you would bust these up into the biggest perfect squares, and I know that 25 is a perfect square, and that would be 5 times 5, and then times 10. So we have a property that says that we can break this into this, the two pieces that are multiplied together. Okay, so the square root of 25 is 5. That comes to the outside, and 10 cannot be simplified any further, so it would be written like this. Let's do another one. Alright, so let's break this one up so that we can see if our pieces will go together. So 12 is 4 times 3. Now I know that 4, when it's simplified, it is 2, and that leaves me with 2 square root of 3 minus 7 square root of 3. So my final answer would be negative 5 square root of 3. I can combine these, I can put these pieces together because they have the same thing underneath the radical. Alright, let's try some distributing. So I'm going to do this times this, and then this times this. And because everything is still underneath the radical in this case, we have nothing in front like we did here, I'm just going to multiply the insides. So 5 times 5 is the square root of 25, plus, I'm going to bring down my sign, 5 times 2 is the square root of 10. Now, I can't simplify this one because there's no perfect square in that one, but I can simplify this, and that would be 5. So I have 5 plus the square root of 10. Alright, let's choose one down here where we have the radical in the denominator. So I'm going to rewrite this as it's the same thing, and we don't want a radical in our denominator, so I'm going to multiply the top and the bottom by the same thing, and that allows me to remove the radical from the bottom, from the denominator. So this would be square root of 9 over square root of 48, and 9 is a perfect square, and that would be 3. And then I have 16 and 3, and those numbers came from here. So the square root of 16 is 4 square root of 3. Alright, so if you were doing this one, you would do the same thing. You're going to multiply both top and bottom by the square root of 2. So you would carry it out the same way. So this would be 9 square root of 2 over 4, square root of 4, which would be 9 square root of 2 over 2. Alright, give it a try. This was page 1.